So let's talk about what the greatest common factor is, what all of this means, all right? So when you multiply terms, you get a product, and each term that is being multiplied is called a factor. Okay, that's called a factor. And when we factor an expression, we are undoing the multiplication. So we're basically doing multiplication in reverse, all right? So in a way, we're going to be using some aspects of division as well, all right? So those are the two blanks, factor and undoing. Everybody got that down?
No, not yet.
Not yet, okay. And if you're on virtual, if you want to do this before or after the lesson, make sure you comment your name, let me know you're here. All right, so we're going to move on to GCF. So GCF stands for greatest common factor. We talked about this before break on our pre-lesson. And it is the largest factor all the terms have in common. So that's why we use the greatest, okay? To find the GCF, it helps to first list all the possible factors of a term. So we're going to list the factors of the term in order to practice getting our GCF, okay? So now we're going to do some examples of stating the GCF. So we're just going to simply find the GCF. We're not going to be factoring out anything yet. We're just going to find the GCF.
3.
So the way that we do this, not 3, that's a common factor, but it's not the greatest. So the way we can verify this is we're going to list out the factors of each one of these terms, okay? So we usually want to start with this most simple one. 1 times 18 is going to give us 18, right? The product of 1 and 18.
Mm-hmm.
The product of what two other numbers would also give me 18?
2 and 9.
Good. 2 and 9.
And 6 and 3.
Good. 3 and 6. So I listed out all of the factors of 18. Can anybody think of any other ones? I don't think there's any more, right? So we're going to move on to 27. So what are some factors of 27? 1 times?
27.
Good. 3 times what?
5.
9. Good. 3 times 9. And there are no other factors of 27, or 2 numbers that we can multiply to give us 27. So we've extended our list, right? So now our goal, if we're finding the greatest common factor, we want to find which number of each of these lists that they have in common is the biggest, and that is 9. That's the largest number they have in common. So our GCF is 9. Excuse me. So does anybody have any questions about that? Are we ready to move on?
Mm-hmm.
All right. So let's go ahead and try number 2. So we're going to list all the factors of 30. So we start with the simple one, which is 1 times.
30.
Good. And then we have 2 times.
15.
Good. 3 times. Good. So we've listed all the factors of 30. Now we're going to move on to find the factors of 36. The first one is always going to be 1 times.
Isn't there also 5 and 6?
Oh, you're right. I forgot about 5 and 6. Thank you.
There's more. They're only. Never mind.
5 and 6. Good. So you're right. 5 and 6. And then we're going to move on to 36. So we also have 2 times.
6 6.
That's true. Yes, 6 times 6. We have 2 times 18.
6 times 6.
Yep, 6 times 6.
So the greatest common factor is 6.
I think it's 12 times 3.
And then we have 12 and 3. Good. And then we also have one more factor. Anybody else know what the last one is?
11.
4 and?
Let me see.
Well, 4 times 10 is 40. What's one less factor than
4
that?
times
9. Good.
Yep, 9.
So that's our extensive list. So now we're going to look for the largest number that they have in common, which is what?
6.
Looks like 6 is the largest one they have in common, right?
Yeah.
So our GCF is 6. Good. So do we have any questions on that one so far? All right. Is everyone ready to move on?
GCF is 9.
Why did I write 9? I circled 6. I don't know what I'm doing. Sorry, guys. My first day back in teaching, and my brain's a little... I circled 6. I don't know why I wrote 9. Yeah, it's 6. Sorry about that. So does anybody have any questions on that? All right. So now we're going to be working with variables to powers, okay? So what a power on a variable means is, a power on a variable is how many times we're multiplying that variable by itself. So, how many x's do we have in x squared?
1.
Good, we just have an x and another x, right? X times x. And how many x's do we have in an x cubed?
2.
Not 2, but 3. So how many x's do these have in common? 2. So this one has 1, 2 from this one, and 1, 2 from this one. And how would we represent x times x? What's a simpler way of saying that?
It's gonna be like 2
X.
and 3.
X to the what power? Alex.
Right.
You focusing?
Right.
Good. The GCF is x squared. So do we have any questions about that? All right. Moving on. So how many y's are there in y to the 4th?
4.
4.
I mean, the greatest common factor is 1.
It is 1, you're right. So we have 4 y's over here and 1 y over here. So how many y's do they have in common?
1.
Just 1. So the GCF here is 1. 1 y. 1 y. So it's just y. Y to the first power, which is also known as just y. So at the end, I'll zoom back out so everybody can see everything if you need me to go back through it. But does anybody have any questions so far? Okay. So now we are going to move on to factoring out the GCF. So we've just practiced finding the GCF. But the reason we ultimately find the GCF is so we can factor it out of mathematical expressions with multiple terms. So when you factor out a GCF, your new leftover expression, or equation if there's an equal sign involved, will have the GCF listed on the outside and your leftover parentheses right next to it. So basically, you're going to be factoring out whatever you find to be the GCF. So we're going to list out the factors just like we have been in the previous ones for each of these terms. Okay? So this one has a single x, so we'll write the x there. And then 1 times what?
30.
Good. 2 times?
15.
Good. 3 times? Good. And then 5 times 6. And then over here, what are some factors of 18? 1 times...
It's going to be like, I remember, 6 times 3.
Good.
2 times 9.
Good job. 3 and 6, 2 and 9.
The greatest common factor is 6.
It is. Good. So in this case, our greatest common factor is, we said 6. Now, notice that the x doesn't have anything to get paired up with right in the other one, so it's not going to be factored out at all. It's just going to be the 6 that gets factored out, okay? So what's going to be left over, it's going to be 6 that gets taken out times, And then whatever other pair that factor had is what gets left inside the parentheses. So this one's going to have what left over?
5 to 3.
5. And that's going to be 5x, right? Because we still have that x that didn't get paired up with anything. The x has to go back. Plus, and then a 3 from this pair right here. So these two end up right here. So you can see where everything kind of went. And that's the end result of our factored expression. Now, does anybody know how we could check and make sure we did it correctly?
Desmos.
Well, yeah, I mean, I guess Desmos could help, but you could also distribute, right? You could distribute the 6 back out and make sure it gives you your original expression, okay? So, does that make sense so far for number 5? Okay. So let's go ahead and try number 6. So in this case, we have, I'm going to list the x's first. We have 2 x's in this one, and then we'll go ahead and do our numbers, okay? So that's going to be 1
Times 8.
times 8.
2 times 8. 2 times 4.
2 times 9.
That's not 2 times.
Oh, why am I writing 18? Sorry, I'm like looking at it. Yeah, you're right. 2 times 4. Good, that's it. And then what about for 12?
6 times 2 and 3 times 4.
Good, so 1 times 12.
The greatest common factor is 4.
2 times 6, yeah. And then 3 and 4.
And 2 and negative. I mean 3. 2 and 3.
Yep. So we're going to find what the biggest number they have in common, which is the 4. And then how many x's do they have in common?
2 or 1.
Just 1. So the other x has to stay behind, right? So what can we factor out of this? A 4 and an x. And then what's left is 2x minus 3. And we could check that by using the distributive property. So does anybody have any questions about this one so far? Okay. And you can also list the x the other way if it makes more sense to you too. You can list them like on the side. So this one we have 4 x's. And then we're going to do the numerical part. So 1 times 8. 2 times 4. And then this one has 3 x's. We'll do all the x's in the same color.
Yeah.
And then it's going to be 1 times 4, and then what else?
2 times 2.
Good, 2 times 2. And then we're going to do it over here, x times x.
The greatest common factor is 2.
It is. Well, not 2, but 2
Squared.
x squared, good. So, now we're going to find how many x's they have in common. So how many x's do these all have in common? 2 x's. So any x they do not have in common is going to stay behind, right? So now we're going to factor out, we're going to look at our GCF, and we decided our GCF is what? 2. So whatever paired up with the 2 is what is going to stay behind. So we're going to take out a 2x squared, because we had 2 x's that we removed from each one. And then whatever was the pair with the 2 is going to stay behind. We'll do it in a
4 and the 4.
good. The 4, the 2, and the 1.
Isn't that a negative 1?
Yeah, it will be when we write it in. You're right. I just write the factors all positive. So that's going to be 2x squared, and then it's going to be a 4x to the second, because there was 2 x's left over. These 2 x's. And then it's going to be plus, and then we had a 2 left, an x left, and then what do we have left in this last one here? What's going to be left for the last term? What's in the
negative 1.
Negative 1, very good. So this is our fully factored form here. And you could distribute this to check your work. So does anyone have any questions about that?
No.
Okay. We're going to do one more. Alright, so the last one we're looking at, let's list out our variables first. So how many p's do we have in this first one?
4.
Good. And then we have our factors, which are going to be 1 times 15, 3 times 5, and I think that's it, right? And now let's do the next one. We got p times p times p. We always have 1 times itself. We have 3 times 15.
And 5 times 9.
Yep, good. We got 5 times 9.
The greatest common factor is 15.
I think it will be, yes, good. And then we have, I think that's it, right, for 45?
I think so.
Yep. And then we're going to do p, or the last one, 30p squared, so that's going to be p times p. And then we have 1 times 30. We have 2 times 15, 3 times 10, and 5 times 6. And now we're going to find, so you're right partially, Xavier. You were right about the 15, but we have to do our p's, right?
Oh,
So how
two.
many? Good. So there's 2 p's that they each have in common, right?
Mm-hmm.
And then what's our GCF, numerical GCF? Not 5, but we got an even bigger one, 15. So that's what's going to come out on the outside. 15 p to the what?
Squared.
Good. And then that's going to be times what's left over. So we have 1p to the second minus 3p, and then plus 2. Now keep in mind, if you have a 1 as a coefficient, you don't need to write it, okay? So you can just write it as 15p squared times p squared minus 3p plus 2. And that will be your final answer. So I will zoom this screen out in case you missed anything so you can see it all. That's what your sheet should look like. Does anyone have any questions on that? Alright, I'm going to hand out your practice sheet. Yes. So I'll go do those. I'll just upload everything right now.
Okay.
So you have it. And then import it.
Stop taking pictures on me. Jack, stop.
Jack, can you stop recording him? He asked you not to record him. You shouldn't be recording anybody in class anyways.
You weirdo. You have to stop.
Does everybody have a worksheet?
Yeah.
Alright. So go ahead and get started on that. List out your factors. So if you have a question, that's fine, but you should start by listing out your factors first. If you can list out your factors, do that step first. So try that part. I'm gonna do it 10 minutes. Alright, so we're missing Jacoby.